Welcome students to the very first video notes section for this semester. Of course, we're beginning with Unit 1 and the very first section in Unit 1, which is 1.1. So the way we're structuring the content this semester is Unit 1 is going to be an introduction to all the functions that we are going to be learning this semester. So you're going to see all the functions for this semester all wrapped up into this unit. And our primary focus will be on evaluating those functions, simplifying expressions with those functions in them, and kind of manipulating them to get equivalent versions. Now, before we get into all of that, it's very important that we review the order of operations. Now, I know what you're thinking. You're thinking, Ms. Lasner, really? This is something we learn in middle school? Like, can't we start with something a little bit more advanced? And my answer to you is no, we cannot, because you never graduate from using the order of operations. It's kind of like, as an adult, you don't just stop brushing your teeth because you're not a kid anymore. Certain things we don't just we never graduate from breathing, right? We have to do that every, how often to live. That's like Pemdas. As you go on and on in your math career, you can never graduate from Pemdas. This is your survival tool. So it's really important that we review what this means. So of course the acronym is Pemdas, and the way to remember it is the Please Excuse My Dear Aunt Sally. Here's what it stands for. So P is for parentheses or any other grouping symbols. The E is for exponents, so that would come next. M and D stand for multiplication and division, but not necessarily like multiplication has to come before division. It just means that this operation, multiplying and or dividing, has to occur before you add or subtract. Now within a category, if you have both multiplication and division, well then you go from left to right would be the appropriate order. But you never want to add or subtract before you multiply or divide. So these kind of go together. So the M and D have to come before the A and S. So let's try with a few examples down here. So in number 1, I see I have some parentheses. And so I'll need to do what's inside the parentheses first. And so I get 6 inside there, and I have to do that first before I square it. See, if I square first and just get a 4, then I'm going to get 4 times 3 is 12 instead of 6 squared. So it's important to take care of the parentheses first, then square. Okay, so then I end up with a 36 because I get a 6, I square it, and then I subtract. That's the last thing I do. See, now I don't want to do 47 minus 6 and then square that number. That'd be 41 squared, a lot different than what this answer is going to be. This answer just turns out to be 11. In number 2, you might notice all of this is within an absolute value. And right here, I'm going to have to do this division part first. Even though it's on the right, it's division, and division has to happen before addition and subtraction. So first I'm going to do 45 divided by 9 to get 5. And then after that, I do negative 18 plus 5. And that has to happen before I take the absolute value, because you have to do what's inside the absolute value first before you apply absolute value. So I get negative 13 when I add negative 18 and 5, and then I apply absolute value, and then my final answer is positive 13. In number 3, I have this expression here, which a lot of times throws students off. They want to do, okay, 9 minus 3, but no. We have these parentheses and exponents and multiplication that we have to do all of this before I can subtract. So I'll start with the parentheses first. So 9 minus 3 times 5 squared. And again, a lot of times students want to multiply 3 times 5 and get 15 and then square that, but we can't do that. According to Pemdas, right, the exponent comes before multiplication. So that's a key thing. You want to remember that. E comes before Mdas, right? So we're going to do 9 minus 3 times 25. We square, we do the exponent first. I haven't even multiplied the 3 yet. Now, so again, before I go left to right, I have to do this multiplication problem. So I get 75. Now I just have addition, subtraction, so I kind of go from left to right. So I'm going to do 9 minus 75 and get negative 66, and then I'll add 1 and get negative 65. Okay, now in number 4, I have this square root. Okay, this is part of the square root function. So first I'm going to do my parentheses. underneath the square root. So I'm going to do 4 times 6 plus 3, which is 9. Now, under the square root, I need to do that multiplication next. So then 4 times 9 is 36. And then I will apply the function. So I've applied the function after parentheses and multiplication. So then I get the square root of 36 is 6. And now I can go ahead and subtract the 19 to get negative 13. So whenever you have a function like that, you need to do the operations that are inside of it first before you can actually operate it. Basically, you want to get down to a single value before you take a square root or an absolute value or something like that. Over here in number 5, I have division right over here. But notice how it's written as a fraction. So I want to take care of what's in the numerator first, all of that, and then also take care of what's in the denominator second, and then I will go ahead and divide. Let me get that out of the way. So I'm going to do the parentheses that are in the numerator first. So I get 11. And then down here, I'll go ahead and do the exponent. And by the way, because this negative is inside the parentheses, that means it's also getting squared. So you can think of that as negative 4 times negative 4, and then minus 7. So in the numerator, I now have 55 minus 1 because I multiply first before I subtract. In the denominator, I now have positive 16 minus 7 because when you square a negative, you're basically multiplying it to itself. And then when you multiply two negatives, they become positive. So then in my numerator, I have 54. In my denominator, I have 9. And then now this fraction means to divide, right? This fraction symbol is a division symbol. And kind of the way it works is it's almost like saying that this is in parentheses. When you have a numerator and denominator, it's kind of like saying those are in parentheses. You have to do them separately, and then you can go ahead and divide. So then 54 divided by 9 would be 6. And so that's our final answer. Okay, now in number 6, I have the same thing, right? I have another fraction, which means I need to do the things in the numerator first, and then the things in the denominator. And then after that, I need to divide if possible or simplify the fraction. So I'm going to start with the numerator. So I have negative 8 minus, and then I'm going to do the things under the square root before I take the square root. So I need to raise 5 to the 3rd power because it's being cubed. So that's basically 5 times 5 times 5. And then I need to multiply 4 and 11 together before I add, right? We want to do multiplication before we do addition. And then in the denominator, I have 3 times 5, so that's 15 plus 1. Okay, so now under that square root, I have 125. That's what you get when you do 5 times 5 times 5, plus 44. And then all of that is over 16. And then when you add 125 and 144, you get 169, and that's all over 16. And then now I can take the square root. Now that I've gotten down to a single value under there, I can go ahead and take the square root. So the square root of 169 is 13. Okay, now before I divide, I have to add, or in this case, subtract the items in the numerator together, because when you have a fraction, it's basically like saying the things in the numerator have to be done first. So then I get negative 21 all over 16. Now, those do not divide evenly. You're welcome to divide them and get a decimal value if you want, but when it's not a pretty decimal, sometimes it's better just to leave it as a fraction. Also, there aren't any common factors between 21 and 16. If there were, we'd want to reduce it, but since there aren't, we're just going to leave our answer like that. Now, if you wanted to get a decimal value for 21 over 16 on your calculator, remember that fractions are basically just division problems. So you would just type it in using a division symbol on your calculator, and it should provide you with a decimal value for that fraction. If you want to do exponents on a calculator, use the button that looks like this. That's how we can raise something to a power. We call it the caret button. And then if you have an exponent with a negative base, make sure you put it in parentheses, Because if you type this on your calculator, oftentimes it'll give you a negative value because it'll do the order of operations. It'll square the 5 first and then multiply by -1. So if what you're trying to say is all of -5 is being raised to the second power, then you have to say it this way. And then your calculator will understand that as -5 times -5 and will give the correct value of 25. Okay, so remember the difference. -5 squared is -25 because you square first and then multiply, whereas -5 in parentheses squared is +25 because you would do parentheses first and then square. So it's good to remember these differences. Okay, now that we're in number 7, we are now given an expression with variables, and we are being asked to evaluate that expression for different values of the variables. So basically, what we need to do is plug these numbers in the space where they appear in the expression. So for number 7, wherever there's an x, I need to substitute it with a 3. So I'm going to start with that. And then wherever there's a y, I substitute it with a 2. And then wherever there's a z, which there's 1 in the exponent here, I substitute it with a 6. So my numerator would be 3 times 2 to the power of 6. And that is all being divided by 6 plus 2, because z is supposed to be switched with a 6 and y is supposed to be replaced with a 2. And then we follow the order of operations. So that means we have to do the items in the numerator first and then the denominator next, and then lastly we divide. So the division is the last thing we do. Okay? So that division bar comes last. Okay, now for the numerator, I need to do the exponent first and then multiply. So that means I have 3 times 2 times 2 times 2 times 2 times 2 times 2, right? 2 to the 6th power, all over 6 plus 2, which is 8. So this ends up being 3 times 64 all over 8. Okay, now here, notice we have multiplication and division, which could kind of happen simultaneously in a sense because they belong to the same group in Pemdas, right? So I can actually divide the 64 and the 8 right now if I want to. 8 can go into 64 8 times because they are of the same type of operation, right? Multiplication and division happen basically they can happen at the same time. So in this case, it was nice for me to do that because then I only have to multiply 3 times 8 and get 24 instead of having to try to multiply 3 times 64, get this giant number, and then divide by 8. So if you have operations within the same order, so multiplication, division go together, you can kind of do them simultaneously like that. Okay, so why don't you guys try number 8? All right, so for the you try, basically we are being asked to replace p with 8, q with 2, and r with 3. So I did that here and got 8 squared minus 2 squared all over 24 divided by 3, and then had to add that to 4 times 3 squared. Then I remembered that if you have a division problem, you have to do the items in the numerator first, and then the denominator, and then divide. And then after that division's been done, then I can go ahead and add this quantity. So I did 64 minus 4 all over 24 divided by 3, which is 8. I squared the 3 and got 9. I multiplied 4 and 9 and got 36. And then this became 60 divided by 8. And so first I just tried to reduce the fraction by dividing both of those numbers by 4. I got 15 over 2. But then since I had to add that to a whole number, I decided to change 15 over 2 into a decimal, 7.5. And then I added that to 36 to get 43.5. The other option is to keep it as a fraction and change the 36 into 72 over 2. And then add that to the numerator. So 15 plus 72 would give me 87 all over 2. So you could also think about it as 87 halves or 43 and 1/2. Moving on to number 9. This is basically called the quadratic formula right here. And a lot of times students, even though they memorize the formula, still can't seem to get the right answers, and it might be because they're not following the right order of operations when they plug in the values. So that's why we're taking time to review it. So I'm going to go ahead and replace b with 3. So I get 3 squared. Let me write it out. And then I'll replace a with -2 and c with 2. And then all of that's being divided by 2 times a. So again, we're going to do numerator first and then denominator. And then within the numerator, I have to do all these operations in the square root first and then take the square root. So let's first square the 3, because then within the square root, I have to follow PEMDAS also. So I got to do exponents and multiplication before I subtract. So we're going to do 9 minus. And since this is one long string of multiplication, you can kind of just multiply it all together. So 4 times -2 is -8 times 2 is -16. All over 2 times -2 is -4. Okay, but then because you're subtracting a negative, you can turn that into a positive. And then under the square root sign, you have a 25, and then that's all being divided by -4. So now that I have a single value under that radical, I can square root it and get 5. But I have to add these together first, right? You've got to do the numerator before, you've got to do the numerator separate and the denominator separate before you can go ahead and divide them. Because the fact that they're all in the numerator together, that's implying there's like a parenthesis there. It's kind of its own way of grouping, and this has to be done first. Okay, so now I get all the way down to here. 8 divided by -4 is -2. And so that's our value for number 9. Why don't you guys try number 10? Okay, so here in number 10, basically we've got m minus the quantity 25 minus n in parentheses minus 2 cubed. So I need to replace this m with 26 and this n with 11. And so I have 2 sets of grouping symbols. I've got brackets and parentheses. So you kind of start with what's inside the brackets, and then once you're inside the brackets, you have to do parentheses first. So that's 25 minus 11, which was 14. Then I'd have to do exponents. So that's 2 to the third, which was 8. Then I do what's inside the brackets. So 14 minus 8 was 6. Then I can go ahead and subtract 26 minus 6 to get 20. So that concludes our 1.1 video. In class on Tuesday, we're going to work through some similar type of practice, and I'll see you then.